This is chapter 6.4, exercises 1 through 6. This section 6.4 of the book has to do with polar coordinates, graphing polar coordinates, and so forth. And in this exercise set, 1 through 4, the polar coordinates of a graph are given. Find its rectangular coordinates. So we need to know a couple things about rectangular coordinates. The first thing we need to know is this. What is a polar coordinate? Well, what you have, it looks like a regular XY coordinate pair, except the first one here is the radius. So that's the first number in a polar coordinate pair. The second number over here is the angle. And how do we know we have a polar coordinate pair? Well, we may have text evidence, such as in the text here of our problem, polar coordinates. And also, if you look at this second value, 2 pi over 3, that is normally going to be an angle in radians. So you look for something with pi in it, or maybe with a degree. An angle can be in degrees, so you see a degree symbol. We'll see examples of both those in these first 4 problems. Well, the things we need to know for this are a couple of equations, and they are equations that we've been working with since the first of the semester. So we have x is equal to r cosine theta, and y is equal to r sine theta. And we say r is the radius, and we have a little song for that. R cosine is x, and r sine is y. So that's something that can help you out in this course. So what we need for our x value is r is going to be 3 times the cosine of 2 pi over 3. And in order to find this out, we have 3 times, and if you know what the cosine of 2 pi over 3 is, which I do happen to know, cosine of 2 pi over 3 is negative 1/2. And if we multiply these together, 3 times negative 1/2, we're going to get negative 3 over 2. And if you happen not to know, as I do, what the equivalent is for 2 pi over 3, you can convert the angle of 2 pi over 3 into degrees. It just might make your life easier. And to do that, the conversion factor is we take this 2 pi over 3 and we multiply that 2 pi over 3 by 180 over pi. And pi over pi will cancel, and what you have left is 2 times 180 over 3. Well, 180 over 3 is going to be 60, and 2 times 60 is 120, so we have 120 degrees. So we can say instead x is equal to 3 cosine of 120 degrees. And so even if we're not really up on what our sines and cosines are, we can go to our calculator and put in 3 times cosine 120 degrees. And for that, we get negative 1.5. And negative 1.5, I hope you should recognize, is the same as negative 3 over 2. Okay. Next, for y, well, y is equal to 3 sine, in this case, of 2 pi over 3, and the sine of 2 pi over 3, I happen to know, is square root of 3 over 2. And so what y is equal to is 3 times square root of 3 over 2. And so really, that's it. So we have that as our y coordinate. And then, if that doesn't come to mind, we can just take 3 sine instead of 120 degrees. And we go to our calculator, we get 3 times sine of 120 degrees. And for that, we get 2.598 to the 1,000th place. And so now we can write down what our polar coordinates are for this. Excuse me, our rectangular coordinates for these polar coordinates. We're going to have coordinate pair negative 3 over 2, comma, 3 square root of 3 over 2. So that's just one way of doing it. And with the using degrees, we had negative 1.5, comma, 2.598. And these really are equivalent. The one on top is the exact value. The one on bottom not exact, but very good. Next on our problem is going to be 3. We have a polar coordinate pair of negative 2, comma, 60 degrees. For that, we have x is equal to r cosine theta, and y is equal to r sine theta. And just substituting in, we have x is equal to negative 2. I happen to know that for 60 degrees, the cosine of that is 1/2. And we just write it out a little. We'll say negative 2 cosine 60 degrees, which equals negative 2 times 1/2. And 2 over 2 cancel, we'll get negative 1. And we can alternatively, if we don't happen to know that, we can use our calculator. And for that, we get negative 2 times cosine 60 degrees, and we get negative 1. Shouldn't be any surprise to us. Now for the y value, y is equal to r sine theta. So we take negative 2 times the sine of 60 degrees. Well, I happen to know that the sine of 60 degrees is square root of 3 over 2. So I take negative 2 times square root of 3 over 2. We're going to have 2 over 2 cancel each other. And remaining we have negative square root of 3. And then if you didn't happen to know, as I did, that the sine of 60 degrees is square root of 3 over 2, you could go to your graphing calculator. In this case, I have my T9SPIRE-CX calculator, and we get negative 1.732. So again, we have our rectangular coordinate form of this these polar coordinates, we have x is equal to -1, comma, negative square root of 3. Or if we just use the calculator to figure it out for us, we would have -1, comma, -1.732. So that will be, these will be our answers to problem 3. My recommendation, again, just kind of glancing back quickly at problem 2, is that it'll be easier for a lot of people if you go ahead and convert this 5 pi over 4 into degrees and work it from there. Problem 4 should be quite easy. Let's go on here to next odd number, problem 5. In exercise 5-6, complete the table for the polar equation, and B, plot the corresponding points. So we have a little piece of polar graph paper here. We'll explain what that's all about, but we have this equation here, r equals 3 sine theta, and one thing that seems to make this thing quite a bit easier is converting these radians into degrees. So if you take pi over 4 and convert that into degrees by multiplying by 180 over pi, you're going to get 45 degrees. Equivalent for pi over 2 is going to be 90 degrees, which is going to be straight up. On the circle 5 pi over 6, you work that out by multiplying by 180 over pi, you'll get 150 degrees. Pi is going to be over here on the left of the circle. That's going to be the same as 180 degrees, pi radians. 4 pi over 3 translates to 240 degrees. So put in 240 degrees. And then 2 pi is going to be equal to 360 degrees, full rotation around a circle. So what that looks like is kind of on our polar coordinate plane. I'll graph these a little later. We have pi over here. So actually pi is over here on the far left. On the right we have 0, which is equivalent to 2 pi, a full rotation. Over here at, all these increments are 10 degrees, 10, 20, 30, 40. So here we have 45 degrees, which is pi over 4. Right at the top of the circle we have pi over 2 radians. Over here at 150 degrees, or 5 pi over 6, that's going to be right here, 5 pi over 6. 4 pi over 3 is going to be down here just 30 degrees to the left. So we have 4 pi over 3. So we have all that lined out. Let's go to the equation now. What we have is we want to go ahead and input each of these angle values. So the R, we're going to say R of the angle pi over 4 is the same as 3 times the sine of 45 degrees. Well, the sine of 45 degrees is square root of 2 over 2, but we'll just go ahead and multiply that. We'll have 3 times sine of 45 degrees, and for that we get 2.12132. I'll just put 2.12 here. So we'll say 2.12, and we'll write this up here in the table. 2.12. The radius at pi over 2 is going to be equal to 3 sine pi over 2. Well, the sine of pi over 2, or sine of 90 degrees, is 1. So we'll have 3 times 1, or 3. So 3 goes into our table here. For 5 pi over 6, we have our radius at the angle of 5 pi over 6 is equal to, from your equation, 3 times sine of 5 pi over 6. And I happen to know that I'll just write this as 150 degrees, sine 150 degrees. And that's going to be equal to 3 times 1/2, I believe, but we'll just put it in here anyway. 3 times sine 150 degrees should get 1.5, 3 over 2. So go over here. I'll just put 1.5 here. Okay, r of pi is equal to 3 sine 180 degrees. Well, the sine of 180 degrees is 0, so what we have here is 0. And then we have r of 4 pi over 3 is equal to 3 sine 240 degrees. And that's going to be equal to, get our calculator, 3 times sine 240 degrees. We get negative 2.98. We'll say about negative 2.6, just to make the graphing easier. So negative 2.6 goes up here in the table. And the last thing, r of 2 pi, is going to be equal to 3 times the sine of 360 degrees. Well, the sine of 360 degrees is the same as the sine of 0 degrees, sine of 180 degrees, 3 times 0. So we have 0 here. So now we fill in the table. Let's go ahead and plot the points. Well, the first point is going to be at pi over 4, which is going to be right here. I'm drawing a little dashed line. And the value we have for that is 2.12. And 2.12, each of these rings here in this polar coordinate graph paper is 1 unit. So 1, 2, so a little over 2. So just on this side of the 2, about here. Next, for an input of pi over 2, or 90 degrees, we have an output of 3. So we go up 1, 2, 3. So that's our second point. Our third point at 5 pi over 6, we go over here to this dashed line I'm drawing, and we go to 1.5. So that's going to be 1.5 right here. Next point is at pi, we have a radius of 0. So that's going to be right here at the origin. The next one we have is 4 pi over 3. Well, 4 pi over 3, we have a radius of negative 2.6. Well, to get to a negative radius, we have to go to the opposite side of the origin. So I'm coming over here and going. So 2.6 is going to be on the opposite side, right about here where I'm drawing that point. And the last one we have is at an angle of 2 pi, we have 0, so we come right back here again. So I don't know how easy it is for you to see or notice, but what this is going to be the graph of a circle, which I'm sketching in like purple here. And just to verify what that looks like, I happened to, before I started this video, went and made a polar equation graph, which I go back to here, and that's going to be r of theta equals 3 sine theta. So we see this circle just above the x-axis and touching with a diameter of 3. So that fits quite well. I do want to mention for problem 6 that you have r equals 2 cosecant theta. Well, one thing that could help you for this is to remember that cosecant theta is equal to the reciprocal of sine theta, or 1 over sine theta. And so you could rewrite this thing as r equals 2 over sine theta, and then fill this in. I think when you work this out, you're going to get you'll get the graph of a line. So good luck with all these problems. I hope this has been helpful to you. Thanks for viewing.